Forensic Science Lecture 16-2, Fundamental Principles of Fingerprints. Fingerprints are a reproduction of friction skin ridges found on the palm side of both fingers and thumbs. This constitutes a unique and unchanging means of personal identification. And through years and years of research, analysts have formulated three basic principles. All of these principles encompass the notion of uniqueness and stability of identification using fingerprints. So the first principle is that a fingerprint is an individual characteristic, that no two fingerprints have yet been found to possess identical ridge characteristics, even with the thousands of prints that have been processed over the years. To this date, the FBI has nearly 50 million prints on record in its database. Not only is it not been found that two prints possess the same patterns, but it's the probability of there existing two identical print patterns in the world is very, very small. Individuality is not determined just by the general pattern or shape, but a careful study of the ridge characteristics, which are known as minutiae. So identity, number, and relative location of these ridge characteristics individualizes print to an individual. There are as many as 150 minutiae on an average finger. Most prints recovered, however, only partial prints. So under the circumstances, there's only a small number of ridges that can be recorded. There have been years of study to try and determine if there is a minimum number of friction ridges that have to be present in order for two impressions to be established positive identification. But there is actually no valid basis. So there's no distinct number of ridges that an analyst needs to identify. In a court case, an expert must demonstrate a point-by-point comparison to prove the identity of an individual or to link one print to another. The second principle is that a fingerprint will remain unchanged during an individual's lifetime. Skin surfaces are designed to provide a firm grip and preventing slip. Through visual inspection, there are series of fine lines corresponding of hills, which we call ridges, and valleys, which are grooves. Shape and form of those ridges is what is actually seen within a finger impression. So fingerprints, as we said before, are reproductions of friction skin ridges found on the palm side of fingers and thumbs. And so through analyzing these different ridges is how we can identify one individual from another. One thing to keep in mind is what composes skin. And skin is composed of layers. The epidermis, which is the outer layer, the dermis, which is the inner layer, and then there's a layer of cells between the epidermis and the dermis, and this is known as the dermal papillae. And this is actually what's responsible for determining the form and pattern of the ridges. Once these are developed in the womb, the pattern remains unchanged throughout life, with the exception of the fact that they're getting better during growth. During growth, but the patterns themselves are not changing. Each ridge is also populated with pores that lead to sweat glands, and the sweat glands is where perspiration is deposited on the skin. So this factors into how fingerprints are actually left behind. when fingers touch a surface, the perspiration and the oils that may be on them are transferred to the surface, leaving the finger's ridge pattern behind, which is what we refer to as a fingerprint. And then the third principle is that fingerprints have general ridge patterns that permit them to be systematically classified. All prints are divided into 3 general patterns, and they're all based on their, divided into 3 classes based on their general pattern. The 3 patterns are loops, arches, and whorls, or what is referred to as law, or loops, arches, and whorls. 60 to 65% of the population actually have loops, 30 to 35% have whorls, and about 5% have arches. So if we're looking at loops, loops have 1 or more ridges entering from one side of the print, recurving, and then exiting from the other side. Loops that open towards the little finger or towards the ulna bone are known as ulnar loops. Loops that open towards the thumb side, which is towards the radial bone, are called the radial loops. Whorls are actually divided into 4 groups: plain, central pocket loop, double loop, and accidental. A plain whorl and a central pocket loop have at least one ridge that makes a complete circuit, which are the top 2 pictures. The double loops are made of 2 loops combined into one finger, which is the bottom left picture. The accidental whorls either contain 2 or more patterns, or a pattern that's not covered by the other categories. So it can consist of a combination of loops and plain whorls, or a combination of loops and tented arches, hence the fact that it's accidental. And that is the picture on the bottom right. Arches are the least common, like I said, of the 3 general patterns. They're divided into 2 distinct groups: plain arches, the simplest of all of the patterns of fingerprints, and this is where the ridges enter from one side, raise and fall, and then exit the opposite side of the finger, kind of like a wave-like pattern, which is the print on the left. Tented arches are similar to the plain, except there's a sharp upthrust or spike, and so the ridge meets at an angle of less than 90 degrees, and so that is the picture on the right. This ends lecture 16-2. There's a quiz next class.